Hey, this is Don once again from Padlock Technologies with another video. This time we are going to do BGP L2 VPN EVPN on service provider networks. Now, if you don't have any idea what, BGP EVPN, I'll put a video over here somewhere in the corner. And if you actually want to see a demo of how you do mp-bgp EVPN with VXLAN on a Nexus platform, another video over here. So most of the times you're going to hear BGP EVPN and VXLAN together in, data center networks, or now what you have the Catalyst networks are, SDA, stuff like that. That's our campus networks. I mean, and the SDA that pretty much does, VXLAN with Lisp and all that other stuff, right? So most people don't know you could do EVPN in service provider networks, but the data plane is different. Now, in campus networks and in data center networks, you're going to use VXLAN for the data plane. In service provider networks, you're going to use MPLS. So when we get in the lab, and this lab is going to be a very intensive lab because it's not just the EVPN. I do a lot of stuff in this one version of the lab, but we're going to focus on EVPN and we're going to focus on point to point, right? For this video. Next video, we'll do VLAN base, and then we'll do something called VLAN aware, which has port channel configuration to it. So let's go ahead and get in the lab, and then I'll just go over just the configurations for EVPN with point to point, okay? All right, so now we're in the lab here. Now this is a pretty intensive lab. So let me shrink this a little bit though, so you can actually see what this looks like. So here's what the lab looks like when I, even a little shrunk down. This has L2 VPNs, VPLS, right? This has regular L3 VPNs, IPv4. This has EVPN multi-home. So that's the VLAN aware uh, instance for EVPN. Then we have some route leaking using OSPF over here. We'll route leak between the two. We also have static routes in here. But today, what we're going to be focusing on is this EVPN point-to-point VPWS site right here. So VPWS is basically virtual private wire service. All right. Think of it as XConnect. XConnect is technically virtual wire, right? Our virtual private wire service. If you know what XConnect is, and if you're studying for your CCNP or CCIE enterprise, you should know what XConnect is, right? Now, since this is going to be a L2 VPN, the links that go from the CE or the PE to the CEs are going to be called attachment circuits, right? In L3 VPN, they're peerings, right? Because you're peering directly to the service provider compared to a L2 VPN, which is an overlay, which the service provider has no idea what kind of routing you're doing. And basically, they're called attachment circuits, or you'll have virtual circuits as well. Now, on G2 and G1 over here, I am running EIGRP. That EIGRP is going to be transparent to the service provider network here in the middle with the circle. And you'll see the neighbor adjacencies will look like we're basically directly connected to each other. Now, this is a service that a service provider can give you, and you can technically have L2 connections in different geographic locations using this technique. But right now, we're just going to use one service provider on that. Now, let us go back to here. Now, all my PEs we have route reflectors here, and they're all doing their pairings there. So let's just go to the route reflector first so I can go over those configurations and just tell you what they are. So we're going to open up just one route reflector here, and these are old. Stretch this out a little bit so y'all can see it. So from a route reflector standpoint, we are doing ISIS as the IGP. So obviously service provider network, I like to use ISIS in the service provider network. So here's my service provider network for ISIS. And then when we go to BGP, let's roll through all of this because this looks like a lot, but it's really not. So obviously I have my templates. You know how I like to do my templates here. So we have our IGP peer policy, and I explain what a peer policy is. This is the stuff that you would do next hop self. You would do, send label under the policy. This one is just going to be route reflector client. And then my peer session is how you build the session up. So I'm just going to do IBGP. Now there is another method where they use EBGP, but you usually see that in the data center. So they would say the spines would be one AS and the leaves would have its different ASs in there. There are some use cases for that, but normally in the Cisco realm, they just want everything to be IBGP at that point. Then we have our cluster ID. This is for route reflector. So if I have another route reflector, which I do in this lab, if it sees its cluster ID in there is the same, it won't accept the routes. And then we're inheriting our peer session policy here. We are not activating BGP IVV4 by default because by default it's enabled. So you use this command to avoid it trying to do an IPv4 session. And then we have our VPN v4, our first AFI, sub AFI. So we have VPN v4. So that's for our L3 VPNs for IPv4. Then we have VPLS here, which is a different address family. We got VPN v4, VPLS. Now, the one thing I want to show you guys is this right here, this command here. So suppress signal protocol LDP. So there's two ways to signal MPLS, or not MPLS, or VPLS. There is a Martini method, which is LDP based. So LDP will be doing the signaling. And then there's BGP based, which is Capella method. I'm using the Capella method because I'm suppressing the signaling protocol of LDP, right? And so once you do that, you are no longer using Martini, you're using Capella method. That's for anybody out there that's trying to go to the service provider realm because they're going to ask you what's the difference between the two. And LDP is going to be targeted LDP. And if you don't know what targeted LDP is, it's going to form a session with the loopback, a targeted session with the loopback, because on L2 VPNs, you really don't want to lose that session or that MPLS LSP. You don't want to lose that LSP. So you're going to say, hey, I'm going to form a targeted LDP session to the loopback, and then routing will get, as long as I can get to the loopback, if one of my links go down or my primary path, how I get there goes down, I'm not going to break the LSP because I'm just trying to figure out how to get to the loop back on the other side for the PE. So you may have a little bit of convergence there, but there's also methods, BFD, then you burn into it, you burn your routes in there. So you got LFA and all that good stuff to minimize the convergence, right? And we're kind of looking like 50 milliseconds kind of thing. And then we have L2 VPN EVPN, which is what we're going to be doing today. So this is the same L2 VPN, but it doesn't work like VPLS. This is where you have, if you watch the video that I talked about in the beginning, you're going to have different route types. So you're going to have in this one, you're going to see a route type of 1, which is your route type, just going to advertise to the network. And then you're not going to see route type 2, which is your MAC and IP. You're not going to see 3s or 4s or 5s, right? Because it's a point to point. There's no need to have all of that. It's just one end to the other end, right? It's just like if you do an X connect, it's one end to another end, so you don't have to learn the MAC addresses per pseudo wire like you would do in normal VPLS, because it's only one way in and one way out. So now that that's all set up, and if we look at show BGP L2 VPN EVPN summary, as you can see, we have some routes here because I'm advertising routes on router 6 and 7, and 4 and 5. That's going to be when we do VLAN aware, you'll see something different there. And then when you see VLAN base, you'll see something different there. When we do VLAN base and VLAN aware, you will start seeing those route type 2s in the BGP table, right? So, or in the L2 EVPN table. So if I just go like this, as you can see, you only have a route type 1 here, which is just the router advertisement, right? Now, this little number right here is the service tag, and I'll show you when we get to 6 and 7, because point to point is a little bit different in terms of a setup. And when I show you the setup on point to point for EVPN, you'll see what I'm talking about. So that's the route reflector. So we're going to go to router 6. Same setup as router 7, so there's no need to really show you router 7. But there is one caveat on here. I'm doing ingress replication instead of using multicast in the service provider core. Now, ingress replication is something, whether it's in service provider or data center stuff, ingress replication is a method that you're going to use when you don't want to run multicast in the core. Now, it does have its it does have its cons because ingress replication means I'm going to replicate that single packet a bunch of times, right? So instead of using multicasting, you send it to a multicast group and you let the network do the replication. The actual head end is taking that packet, making a copy of it, sending it out, right? So it's for people that don't want to use multicast, that don't understand multicast, but still want to run EVPN. Now, where do we actually change that at? Well, in these routers, now these are CSRVs, I believe. There is a command called L2VPN EVPN, and then you do router ID, loopback, whatever, and then you say replication style or replication type ingress. So what we're going to do here is we will look at that section L2VPN EVPN, and here it is right here. So you will do L2VPN EVPN, replication ingress, and router ID loopback 0. If you don't do that, this will not come up at all, right? You won't be able to actually do EVPN, at least from the service provider style SRV, like CSR routers or stuff like that. The next thing you need to do is this configuration here, which is create the L2 EVPN instance. So what we're doing here is we're going to do an L2 EVPN instance, give it a number, and then you have to specify point to point. If you don't specify point to point, then you have to specify VLAN base or VLAN aware. You got to give it a route distinguisher because, as you know, with MPLS or with L2 VPNs or L2 VPNs, the route distinguisher makes the route unique, right? And the RD is what? 64 bits, right? So just remember that. But the route distinguisher makes the route unique. So this is where you can have the same IP address, but it's going to look unique based on the RD value. Then the next thing you have to do is create a context. Now you're going to use VPWS, which is virtual private wire service context, and then you give it a name. Then after that, you're going to do service target, and this is where you're going to specify the ID or I forgot, I think it's the VC ID, I believe. Don't quote me on that. But it's a certain number that's going to be on the other side, right? And then you're going to say my source is this number. And then you're going to do a member, you're going to add a port. So this port here, G6. So if I go to show run interface, let's just do G6. As you can see, only thing I did here, there's no IP address here. I created a service instance 6 and I said encapsulation untagged. Now, I could do L2 forwarding to, forward CDP messages and stuff. You know what? Let's do that now while I'm at it. You might as well watch me do it here. So interface G6 service instance 6, that's 6, right? Ethernet. And then we're going to do L2 forward. Is it L2 protocol forward CDP? All right, we'll do it on that end. And then we will actually do this on 7 as well. Now, I don't believe CDP is actually turned on. I think this is 5 here. So now let's go to interface G5, service instance 7 Ethernet, and then L2 protocol forward CDP. So now CDP packets will get sent over this EVPN. And then I need to actually turn it on at the routers. Now, this may take a little bit of time to actually show up. Oh. Well, while that's doing that, because I fat fingered that, let's look at the VC stuff. So to actually look at your connections, you're going to do show L2 VPN, EVPN, and I believe it's VPWS, and then VC detail. Oh, all detail. Let's see, we got detail. There we go. So that is the very detailed information about the circuit that was set up. And as you can see, my source is 2006. I'm targeting 2077. You see my next hop is router 7, and you see my local label is 618. The remote label is 718. So let's not go with the detail here. Let's just do all. So as you can see, here is my point-to-point setup. As you can see, type point-to-point. You see what interface is in. This is my EVPN or EVPN instance, and this is the Lake 6. So this is actually it's bridging it together. Now, when we do VLAN base and VLAN aware, you have to actually create a bridge domain. With point-to-point and EVPN, you do not need to create the bridge domain. This is actually just merging those two together. Bridge domains merge interfaces with, VFI context and stuff like that. And VFI is a virtual forwarding instance. So back to this, because I did forward that. Run. But this is probably going to take forever. Show CDP neighbors. And there we go. We actually see it on the other side. So I'm on router 2, which is this router here. And now I notice that I have a CDP neighbor through my service provider network for router 1. So let's see if this actually shows up now. So CDP neighbor. There we go. So CDP is being shown because I'm allowing CDP to go over the service provider network, which is going to be with MPLS and all that, right? Again, we're not using VXLAN for the data plane. We're using MPLS. So now, if we go to router 2 and I do show IP EIGP neighbors, you see I have a route. And if you don't know, the links are 172.16.7.124. And on router 2, I'm .2. So I see a EIGRP neighbor, router 1, like I'm directly connected to it, but I'm going through the service provider core and I'm using MPLS. Right? So now if I do show IP route EIGRP, I see the loopback, which is 10.7.255.1, which is on router 1, and we can verify that there. All right, and now we just have to ping it 10.7.255.1, and we'll source it from our loopback. And you see, there we go. So it makes it look like it's directly connected, right? This is EIGRP, looks like it's directly connected. We're not using BGP. We're not doing an L3 VPN. We're repairing and then we're redistributing routes. We're not doing any of that. Now, again, you control the routing. Service provider does not control the routing. They just give you a transit so you can actually form the peering and you own the routing. So if anything goes haywire or anything from a routing perspective gets messed up, it is your job to fix it. You cannot call the service provider and say, hey, I need you to fix this routing that I set up. All they're going to say is, hey, we gave you an overlay VPN. It's transparent to us. We can't fix your internal routing. So be careful when you want to pick between L2 VPNs and L3 VPNs. So now let's do a little bit of Wireshark in here. Now, I'm not sure what interface this is going to show up on. So we're going to Wireshark both. Slide this over here. Okay, so you see the EIGRP packets. Let's take a look at that. So as you can see, here's the label, the top label, the transport label. This is 16.211. And then we have the service label, which was that 718 that we saw before. And then now this 16.211 came from router 2 because iOS XR starts at 16. So I know that 16.2 is coming from router 2. If it was 16.3, it would be coming from router 3. And then we see this control word. This is usually what you're going to see in an L2 VPN. They have this control word. There's a lot of stuff you can manipulate here. But again, this is a service label, so it's the P routers in the middle. They don't care about any of this. All they care about is the top label. And then we see the frame, and then we see IP. Now, if we look at the frame, we should see that header there that says 0x0800. You should know that. By the way, there's an ether type that says, hey, the next packet after me is an IP packet, which, as you can see, is an IP packet. MPLS, I believe, is 0x8488. Don't quote me on that, but if I remember that off the top of my head, that means I haven't forgotten everything. And then EIGRP, right? And then you see a parameter. We see the autonomous system number. Here's some of the parameters here. K weights. Nobody ever messes with K weights. I suggest you don't mess with the K weights. But K weights are basically calculations. If it's a 1, that means I'm going to take it into I'm going to take it into consideration when I'm doing my calculations. And the ones that are on are bandwidth and delay. If you turn any of this out, excuse me, if you turn any of this other stuff on, you could potentially break EIGRP if you don't know what you're doing. So don't really mess with the metric weights, and they call them K weights. And then we have our other stuff here. So now if we go back to router 6, now that I know it's going to 2, if we do that same ping again, let's see, actually wrong. Let's do that same ping again. There we go. Because now I know it went to router 2. Same function here that we saw before. We have our Ethernet, our MPLS labels, control word. We see the Ethernet. We see the Ether type, which is telling us the IP packet. Here's the IP packet. And then here's the ICMP payload that's in there. And that is EVPN service provider style in a nutshell. Now, this is the point-to-point version. When we go to the VLAN based or the VLAN aware based, which is for multi-home, but we're going to do VLAN based next, you will start to see in the EVPN table those different route types. If you found this video informative and you really like stuff like this, you really like technology being broken down in layman's terms, don't forget to share, comment, like, and subscribe to the channel. Bring more people to the channel so they can learn cool stuff like this, right? And then, hopefully I can, mentor a whole bunch of engineers that's coming up in the game, and I can make a bunch of little me's and they can get better than me eventually. This is Don from Padlock Technologies. Again, I hope you like this video. Thank you and have a nice day.